The revolution in consciousness studies is hiding in plain sight. This video presents the revolutionary choice-making theory of consciousness as first described in the book The Origin of Consciousness, The Natural Selection of Choice-Making Systems. There is a continuous evolutionary lineage of choice-making systems from the earliest life forms to the present. All functions of the human brain are choice-making, including instinct, movement, and speech, or choice-making support, including senses, memory, and emotion. We make thousands of choices every hour, including each movement of your eyes reading this sentence. Choice-making produces the feelings associated with consciousness: awareness, agency, sentience. The self is real and descended from central choice-making functionality first developed more than 600 million years ago to mediate choice of movement direction. A taxonomy of choices can be used to guide the future of consciousness research. Choice is the selection of one option when two or more are present. Most definitions of choice imply the presence of a deliberative agent, but not all choices require such an agent. Natural selection itself is an example of an agentless choice-making system. We now examine the natural selection of choice-making systems, beginning with single-cell organisms. The first imperative of life is the acquisition of nutrients necessary for survival and reproduction. In single-cell organisms, this choice takes place at the boundary of the cell membrane. The entry of nutrients into a cell was first accomplished by open channels and later by active transport. Active transport choices were written in the language of the molecular protein structures embedded in the cell wall. This choice of what chemicals are allowed entry into the cell is distributed across the cell membrane. This makes it an example of an automated and decentralized choice-making system. A food acquisition strategy is the method or methods that an organism uses to locate, select, and ingest nutrients. We will address the three most important food acquisition strategies in evolutionary history. Single-cell organisms floated in a liquid environment and took nutrients from that environment as they were encountered in random movement. We call the random floating encounter with nutrients the encounter strategy. The encounter food acquisition strategy still exists in microbial life and also in sessile animals such as coral and sponges. The encounter food acquisition strategy today. The evolutionary lines of animals and plants separated about 1 billion years ago. We will now follow the line of animal evolution, although many of these concepts also apply to plants. What most distinguishes animals from plants is the capacity for self-powered movement. Animals that could move toward food or through fields of food would be more successful than those that waited for it to show up. At first, animal movement was as random as floating, still the encounter strategy. But about 700 million years ago, multicellular animals developed the ability for directed movement. Animals with directed movement could use much more complex choice-making in searching for and finding food. The research of Dr. Raju Tomar and Associates, published in Cell magazine in 2010, suggests that search and find choice-making appeared very early in animal evolutionary history. Tomar found that annelid worms have a brain structure homologous to that of vertebrates. The authors claim that their data dates back the origin of higher brain centers to pre-bilaterian times, approximately 600 million years ago. The authors go on to say that we speculate that the first function of these brain centers was to distinguish between food and non-food and decide about directed locomotion toward identified food sources. The search and find food acquisition strategy today. Animals with directed movement cannot, as a rule, move in two directions at once. Directed movement required some central function to mediate the mutually exclusive choices about direction of movement. We call the collection of neurons that perform this function the choice-making core. This is a functional and not necessarily physical description. Over evolutionary history, this choice-making core evolved to become the modern self. The choice-making theory of consciousness may be the only theory that provides a sound scientific explanation for the evolution of self. The third major evolutionary stage of food acquisition strategies was that of predators about 450 million years ago. We call this strategy the pursue and capture strategy. The choice-making demands of pursuit are iterative and interactive and involve even greater complexity than search and find strategies. At the search and find and pursue and capture boundaries, automated choice-making reached the limits of its utility in finding food. Open, non-automated choice-making emerged to produce rapid-fire choices, the outcomes of which could not be predicted. The pursue and capture strategy also initiated the predator-prey arms race. This competition between species drove increasing complexity in choice-making for both predators and prey. The pursue and capture food acquisition strategy as it exists today. The next big change in choice-making complexity came when animals began to cohere in social groups approximately 150 million years ago. Social groups provided advantage in food acquisition and improved protection from predators. New choices included competition for food, mating, and status, and selection pressure for improved communication skills. The first primates emerged from this group approximately 75 million years ago. The human line of descent separated from chimpanzees approximately 6 million years ago. The path from hominids to present humans involved increases in choice-making complexity and corresponding increases in brain size. This involved such factors as social competition for food, mating, and status, sexual selection for health, strength, and intelligence, tribal groups, tribal conflict, family groups, child rearing, tool use, group hunting, PC, and gathering, SF, control of fire, constructed shelter, language, storytelling, and much more. Humans exhibit a full range of choice-making abilities along an automated to open continuing choice-making continuum. At the automated end of the continuum, we have low variable, relatively small number of permutation choices with pre-programming of those choices. This includes reflex, instinct, autonomic regulation of internal organs, sensory processing, and language syntax. Semi-automated choice-making includes emotions, feelings, intuition, autonomous memory, learned movement, other learned choices. Open, high variable choices lie at the end of the open-ended continuum, relatively large number of permutations with the interaction of rule sets, including directed movement, sensory focus, memory interrogation, speech planning, logic, and imagination. Traditional consciousness terminology can be reimagined through the lens of choice-making. Free will is real. We make thousands of choices every day. There is not enough computing power in the universe to predetermine human choices. Qualia exists because it is useful in choice-making. The subjective experience of redness is made up of complex associations that are both epigenetic and learned, such as associations with heat, danger, and sexuality. The compounding of such adaptive associations over millions of years could account for the ephemeral nature of qualia. Awareness is the feeling associated with the choice of sensory focus and the self's continuous choice-making engagement with internal and external realities. Consider how we can personally observe choice-making. We are making choices all the time. Pay attention to the small choices in daily life while walking, shopping, sorting clothes, playing music, speaking, or writing, or watching this video. Notice the movement choices of athletes, constrained by a strict set of movement rules. Imagine how choice-making would become harder with the loss of any of your choice-making support functions, senses, memory, emotions, or imagination. All mental abilities can be tested against how they help us make better choices. And observe the complex choice-making in animals, dogs, cats, birds, and even insects. The brain of the fruit fly has been shown to have over 100,000 neurons. It exhibits such complex behaviors as navigating via visual cues, complicated grooming, and sleep. Animals are conscious relative to humans in proportion to the complexity of their choice-making systems. So, main conclusions. The human brain is the centerpiece of a complex choice-making system. Our choice-making system is the product of the natural selection of precursor choice-making systems dating back to the beginning of life on Earth. Yourself is a real part of that system, not an illusion or supernatural phenomenon. The principal purpose of the brain is choice-making. Choice-making, in fact, may be the only way to view the brain as a coherent whole. Consciousness is the functioning of the human choice-making system, or put more simply, consciousness is choice-making. Consider, for more information, going to this website where you can see the poster from the Science of Consciousness conference in Interlaken in 2019, or consider getting the copy of the monograph, which provides a much more complete presentation of the choice-making theory of consciousness. And I welcome correspondence and comments at this email address.